Hydraulic model studies of pump intake structure for Nagalwadi lift irrigation scheme Madhya Pradesh, India. Geometrically similar 1:12.5 scale 3D comprehensive model. Nagalwadi lift irrigation scheme is a major irrigation project undertaken in Madhya Pradesh, in which water will be lifted from Narmada River, to provide irrigation facilities to the water-scarce areas in the upper reaches of Barwani and Khargone district. The project command area has been selected to irrigate 38,412 hectare land. For this project, Laxmi Civil Engineering Services Private Limited have entrusted Infraplan Engineering Services Private Limited for carrying out the comprehensive 3D physical hydraulic model studies at Infraplan Hydraulic Laboratory, at Pune, India. The project consists of 7 pumping stations. The physical hydraulic model studies for pump sump number 1 has been proposed. The pump station 1 is proposed with 5 pumps, with peak discharge of 15 cubic meters per second. Each pump is having a design discharge of 3.75 cubic meters per second. The pumping station 1 consists of the inlet channel, 4 bay, and 5 pump bays. The trash rack is provided for each of the pump bay. The silt trap is also provided to trap the silt before entering the pump bay. The minimum drawdown level and high flood levels are fixed at 124.5 meter and 142.3 meter respectively. The pump bay consists the bell mouth, suction pipe, and baffle wall arrangement. Components constructed in model are: inlet chamber, intake channel, the 4 bay, the piers separating the pump bays, the bell mouth inlet and suction pipe, and baffle wall. For experimentation, various combinations of pump operations were selected by maintaining the water level at MDDL. The simulation matrix considered for the study is shown in the table. The model studies were also conducted for 1.5 times Froude's number discharge, as suggested by Hydraulic Institute guidelines for different pump operating conditions, using similar matrix, so as to assess the efficiency of the pump sump, with water level maintained at MDDL. During experimentation, the water level is maintained in the model at minimum drawdown level, for different pump operating conditions using valves. The vernier gauge of least count 0.1 mm is used, to determine the water surface elevation in model. Next, the flow through the suction pipe is regulated, by means of calibrated flow meter for the desired pump combination. As the flow condition stabilizes, the observations are taken. First, the flow in the sump. Possible existence of subsurface vortices was visualized by injecting the dye. Second, the surface vortices were inspected visually by injecting the wooden dust. Finally, the results obtained are: the flow was mostly uniform over the approach channel. No eddies, and no surface-subsurface vortices were observed. Some water level variations in the form of dimples were noticed, for experiment number 1 and number 2, in front of pump number 2 and number 3. For the studies with 1.5 times Froude's number discharge, similar flow condition was observed. In view of the above flow conditions, for all combinations of operating conditions of the pump house, were acceptable and satisfactory. In view of this, the following modifications in the design are recommended, based on physical hydraulic model studies for the pump intake structure. Desilting pump is recommended, and will be able to desilt the sump as far as possible, but it will be also helpful for dewatering of the main sump. Small sump is also recommended inside the main sump, to accommodate the desilting pump. It is recommended to provide baffle walls, with drain holes provided at suitable interval, both horizontally and vertically of diameter 0.1 meter. This arrangement will improve the flow conditions.